Hello all and welcome back. In this video, we are going to cover VPC NAT Gateway followed by a quick demo. Instances launched in private subnets, that is subnets associated with route tables with no routes to Internet or NAT, cannot access the resources in the Internet. NAT or Network Address Translation devices launched in the public subnet enables instances in a private subnet to connect to the Internet but prevents the Internet from initiating connections with the instances. Instances in the private subnets would need an Internet connection for performing software updates or trying to access external services. NAT device performs the function of both address translation as well as port address translation. Also, NAT prevents instances from being directly exposed to the Internet and having to be launched in a public subnet and assigning an elastic or a public IP address to it. AWS NAT Gateway is a AWS managed NAT service that provides better availability, higher bandwidth, and requires less administrative effort. Public NAT Gateway is associated with one elastic IP address which cannot be disassociated after its creation. Each NAT gateway is created in a specific availability zone and implemented with redundancy in that zone. NAT gateways do not support security groups for now, but you can use NACLs or network ACLs to control traffic to and from the subnet. AWS also supports private NAT gateways now. A private NAT gateway can help enable communication between overlapping CIDR blocks. It uses a unique private IP address to perform network address translation for overlapping source IP addresses and a unique destination address that load balances the destination overlapping IP address. In this demo, we are going to set up a NAT gateway to enable connectivity from instances in the private subnet to the Internet. Let's navigate to our VPC dashboard. Let's navigate to the resource map. We have a VPC A with two subnets created in the US East 1A AZ. The public subnet is associated with the custom route table with a network connection to the Internet gateway, while the private subnet is connected to the main route table with no network connections. Let's navigate to the EC2 dashboard. We are going to create two EC2 instances, one Bastion host for testing, and one instance in the private subnet. Let's go ahead and launch our instances. Let's name our instance VPC A, private server. We are good with the Amazon Linux AMI with 64-bit architecture, T2 micro instance type. We are going to use the same demo key pair we created. Let's go ahead and edit the network settings. We are going to associate the instance with VPC A. The instance is going to be launched in the private subnet with no public IP. Let's go ahead and select an existing security group. We had a security group created which has the SSH enabled from everywhere. That seems fine for now. The rest of the settings look good. We do not need any IAM role for this demo. Let's go ahead and launch our instance. The instances are launching. While the private server is being launched, let's go ahead and launch our Bastion host as well. Let's launch our Bastion host. Let's name it VPC A Bastion host. We're good with the Amazon Linux AMI, 64-bit architecture, T2 micro instance type. Let's select the key pair to be the same demo key pair. Let's edit the network settings. Let's select the VPC A. The Bastion will be launched in the public subnet with the public IP enabled. And let's select the same existing security group that we created, which has SSH enabled from everywhere for now. The rest of the defaults look good. Let's go ahead and launch our Bastion host. Let's navigate back to our instances and check the instance state and the status check. Still not running. Let's wait. It usually takes some time. And yes, both the status check has now passed. Let's now copy the public IP address for the Bastion host. Let's open the terminal and we'll SSH into the Bastion host. Let's try to check the connectivity from the Bastion host to the internet. We are going to do a simple ping test to google.com, and it works. The Bastion host being launched in the public subnet does have access to the internet via the internet gateway. Let's copy the IP address of the private server. Let's SSH into the private server and let's try to run the same ping command. And the ping does not work. As the private instance does not have any outgoing network connectivity, it's not able to reach the google.com. Let's keep the ping running and let's try to now configure our NAT gateway. Let's navigate to our VPC dashboard, NAT gateways, and let's create our first NAT gateway. I'm going to name it VPC NAT Gateway. Let's select the subnet. The NAT gateway should be associated with the public subnet as we are creating a public NAT gateway. Let's select the public subnet. The connectivity type is public. Remember, NAT does support private NAT gateway as well now. Let's allocate an elastic IP address. Remember, elastic IP address is charged when not in use. Once you release the resources, be sure to delete or release the elastic IP address as well. I think we are good. Let's create our NAT gateway. The NAT gateway is now in the state pending. Let's wait for it to be available. And it's available. Let's go ahead and configure our route tables. We need to edit our main route table. Let's go ahead and add routes to our main route table. Let's edit the routes. We are going to add a route to anywhere, the target being our NAT gateway. Let's select our NAT instance here. Save the changes. So we have two entries in our main route table now. The one is a local default route and the other with the destination anywhere to our NAT gateway. Remember, NAT gateway will only allow outgoing traffic from our private instances. It will not allow incoming traffic from the internet to our private instances. Let's go back to our terminal and check. And yes, the ping command have started responding once we set up the NAT gateway and the routes was configured. The private instance is now able to route traffic to the internet via the NAT gateway. Let's do a quick cross check. Let's go back to our routes. Let's edit our routes and remove our NAT gateway route. Let's go back to our terminal and let's try the ping command again. And it fails. I hope you found the demo useful. Thank you all.
Alright, that was it. Thank you for watching. You can check out my website and connect me on LinkedIn and Twitter. If you enjoyed this video, please give it a thumbs up. For any feedback, please leave a comment down below. To see more videos like this in the future, hit the subscribe button. Thank you.